Chalo. So let us begin, everyone. Yeah, today we are going to start with the huge chapter P block. Okay, so start with the P block. We have to do some of the basics. Yes, we have to start with some of the basic. This is your periodic table. So come on, tell me, everyone, how many blocks this is the P block. But in periodic table, how many blocks are there? Come on. In periodic table, Kevin, Prasanthi, Rahul, Sarjna. How many blocks? Not the elements. Kirtini. There are 118 elements, I know. I am saying how many shells, how many block is there. Like this is the chapter P block. Similarly, Kevin, Prasanthi, what is SPDFSIS? 2S block we have. Kevin? Correct, Sarjna. So we have S block, P block, D block, F block. Correct? We have S, P, D, F. Yes, S, P, D, F. So can everyone identify?
I typed S 2 times, sir.
Okay. Can in chat box, come on, everyone. Can you tell me where is the S block? Where is the S block? S block consists of what? Yes, S block is consist of what? Okay. Before that, let me tell you what are groups and periods. I'll start from very basic. So group, all this vertical, yes, all these vertical columns are nothing but your groups. Correct? All the vertical columns are nothing but groups. So over here, everyone, in the periodic table, how many groups are there? Yes, in the periodic table, how many groups are there? In periodic table, simple question. How many groups are there? Yes, Prashanti. I hope you are not doing the project work, Prashanti. How many groups? Correct, Ragul? The vertical are group, no, Kirtini. The vertical, there are group. No, Prashanti. I'm talking about groups, not the blocks. Look over here. Group 1, group 2, group 3, like that. This is 1, Prashanti. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, similarly 18. So this is 13 to 18. Okay. So group, there are 18 groups. And how many periods are there? The horizontals are the period. How many periods are there, everyone? Is it 7 or is it 9? Sarjna says 8. Is it 7 or is it 9 or is it 8? 7, 8, 9. Okay, everyone is saying 7, 7, 7, 7. Okay, 1, 2, 3, 4, 5, 6, 7. What about this two? Aren't they 8 and 9? Like, why are not we considering them? Yes, Prashanti, Ragul, Kirtini. Why are not we considering them? What about them? So what? Lanthanide and actinide, we should not consider them. Like, they do not have rights. Yeah, their fault is they are lanthanide and actinide. So we are going to discriminate them. Yeah, we are the discriminators, the apex of food chain. Yeah, we are the discriminators, isn't it? Correct, Sarjana. Okay, look over here. Let me upload the periodic table in little bit high resolution. Just a minute. Okay. Okay, look over here. Is it visible, everyone? Just a minute. Now it is fine. Is it visible? Come on, give me yes or no. Is it visible? Yeah? Okay. So we are not discriminating over here. Prashanti. Okay, over here, what is happening? Look at this. What is this? 57. After 57, Prashanti, what should come? Anmoldeep, what should come? 58. correct? But what we are writing over here, 72. So where this 58 to 71 has gone? So 58 to 71 is a part of this itself. Okay, that is, we have just picked it up and kept it on side, but it is still the part of that, correct? Similarly, Anmoldeep, look over here, 89. After 89, we are directly jumping to Rutherfordium, that is 104. Correct, Sarjana? Yes. Over here, what is missing? 90 to 103 is missing. So where are they? They are over here, 90 to 103 till Laurentian. Are you getting it, everyone? So they are the part of the sixth period and the seventh period itself. They are the part of sixth and seventh. It is just we have picked them up and kept it on side because they show some similar property and different to that of their present in the D block. Okay. So write it down, everyone. Group 1 and group 2 is your S block. Group 1 and group 2 is your S block, correct? Group 13 to group 18 is your P block, correct? Then group 3 to group 12 is your D block, correct? And F block is present in the D block itself. And that's why D block, what do we call them? D block, we call them as a transition metals. We call them as transition elements. Okay, D block, we call it as transition elements. And F block, we call it as inner transition elements. Why? Because they are present inside the D block itself. It is just Prashansky, we have kept them, we have picked them, and we have kept it separately due to some properties. Is it clear, everyone? And this is the F block. Come on, give me yes. Is it clear? Okay, S, P, D, F. S, P, D, F. Okay. Now, everyone, why any particular element is present in that place only? What is my question? Understand it properly. Why nitrogen is present over here? Why not nitrogen can come in S block, B block, F block? Yes, Prashansky, Sajna, Kevin, Ragul, Anthony, Tiffany. Due to atomic mass, is it? What else? What else? Okay, due to their atomic size and similarity of properties. Okay, what else? What else? Anmol Dip has given the answer which I wanted. Correct, and yes. So over here, because your nitrogen, your last electron, Sajna, Prashanti, your last electron enters in which shell? Yes, it enters in which subshell? Your last electron, nitrogen, everyone. What is the atomic number of nitrogen? Yes, what is the atomic number of nitrogen? Yes, it is 7. So if I write down the electronic configuration, it is 1s2, 2s2, 2p3. So the last electron is entering in the p subshell, and that is why Sajna, Prashanti, they are present in the p block. Is it clear, everyone? So the last electron, it enters in which subshell? That depends where your element is. Okay. Now tell me honestly. Okay, you have to be 100% honest. How many of you know how to write down the electronic configuration? How many of you know, like, you, even if I give you the atomic number 40, can you write down the electronic configuration? How many of you know how to write down? How many of you know the trick to write down electronic configuration? Tell me yes or no. Come on. It is I am going to teach you if the answer is no. So tell me yes or no, that do you know how to write down the electronic configuration? Okay, and knows it. Anmoldip knows it. Tell me honestly, I am again telling you. I don't know the trick, sir, but I can write it. Okay, Ragul says no. Okay. I don't know the trick. Okay. Chalo. I'll tell you how to write down the, Anthony does not know it. Okay, fine. I'll tell you how to write down the electronic configuration. So I have started from the very basic of the periodic table. I am assuming that you do not know anything. Okay. So I'm starting from that. Okay. Chalo. So everyone, write down the electronic configuration table with me. So write it down like this: 1s, on the same line write 2s, 3s. Some of you may already know this. 4s, 5s. Some of the book it is done vertically. 6s, 7s. Okay, 2p, then above 2p, above 2s, 2p, 3p, 4p, 5p, 6p, 7p. Then above this 3p, write down 3d, 4d, 5d, 3d, 4d, 5d, 6d. Then above 4d, write down 4f. So make a triangle like this, 5f. Then if you have a scale, very good. I do not have scale over here, but then draw the line. Draw the straight line. Draw the straight line. Although I do not have scale, okay. So draw the straight line. Those who know very well, good. Those who do not know, please write it down. Draw this line. Okay. Then give the number to the line. 1, 2, 3, 4, 5, 6, 7. Now look over here, everyone. After drawing this table, you have to go in order. So first line says what? Ragul, the first line says 1s. Correct. Next, so first line is over. Next line says 2s. So 1s is lower in energy than 2s. I am going according to the energy level. Okay, after 2s, your second line is over. Then you have the third line which says 2p, 3s. So after 2s, what you have? 2p, 3s. Then after 3s, what do we have? 3p, 4s. 3p, 4s. After 4s, what do we have? 3d, 4p, 5s. 3d, 4p, 5s. And this will continue. And this will continue with the fifth line, sixth line, seventh line, and eighth line. Is it clear, everyone? Sarjana, Ragul, Anthony, is it clear? Yes?
So can you repeat the last part again, sir?
I am coming to that. Okay. Now look over here. So maximum, tell me everyone, maximum electron, you have s orbital, you have p subshell, you have d subshell, you have f subshell. In the s subshell, I am coming to that. Okay, Anthony. To s subshell, how many electrons are there? S subshell, correct. And how many electrons, everyone, in S subshell? Yes, Ragul, correct. Sarjana and Moldeep. Anthony, it is not 7. It is not 7. Who told you it is 7? No. S is 2. In the S, why there are 2 electrons? Sarjana and Moldeep. Why there are only 2 electrons in the S subshell? Because we have only one orbital in the S subshell. Okay, in that orbital we can accommodate maximum 2 electrons. Correct. In the P, how many orbitals of P we have? Maximum electrons in the P. How many maximum electrons can stay in P? Yes, correct. And Moldeep, 3 orbitals, 6 electron, correct. And correct, Kevin. P is 6. D, how many electrons, everyone? D, come on, tell me. D, correct. It is 10. In the F, it is 14. Now again coming to this diagram, Anthony, those who have not understood, draw this table. Okay, then go in the order. Look at the first line. First line says 1s. Anthony, then go to the second line. After first line is over, go to the second line. It says 2s. After 2s, go to the third line. It says 2p, 3s. So write 2p, 3s. Then go to the fourth line. 3p, 4s. So 3p, 4s. Then go to the fifth line. 3d, 4p, 5s. 3d, 4p, 5s. Then go to the sixth line, seventh line, eighth line, and so on. Is it clear, Anthony? Is it clear? Okay. Now let us say, take any atomic number like iron. What is the atomic number of iron, everyone? Fe. What is the atomic number of iron? Yes, and Anthony, Kevin, Sarjana, Ragul. What is the atomic number of Fe? Anmoldeep. Yes. Come on, sing a song in your head. I know some of you sing the song of chemistry, yeah? You can sing a song by muting your mic. Otherwise, my ears will bleed by hearing your song. Yeah? Yes, Fe, correct, Kevin, correct, Sajna, correct, and it is 26. Okay? So, everyone, okay, first let me complete this, then I'll come to that basic also. Okay, Fe is 26. Fe is 26. Correct. So 26 I have of Fe. So I'll start filling the electrons, Anthony. I'll start filling the electrons. In the S, Anthony, maximum electrons that could go in the S is 2. So 1s, 2, 2s, 2, 2p maximum can go is 6, 3s maximum it can go is 2, 3p, p orbital maximum 6, s maximum 2. So what is the number? Calculate. 2, 4 plus 6, that is 10, 10 plus 2, 12, 12 plus 6, 18, 18 plus 2, 20. How many are left, Anthony? 6 are left. 20 I have already written. 6 are left. So 3d 6. Is it clear, everyone? So this will be your electronic configuration. This will be your electronic configuration. Now, no matter, even someone give you atomic number 55, someone give you atomic number 88. If you know this table, if you know this trick, you can write down the electronic configuration without doing any mistake. Is it clear, everyone? I hope everyone is clear. Okay. Okay. So I'll give you one number. Okay, I'll give you one number. Tell me your last electron enters in which subshell. Okay, I'll give you one number. Tell me your last electron enters in which subshell. Okay, take the number 53. Take the number 53. Chalo. Take the number 53 and write down the electronic configuration of 53 and tell me in which subshell 5a, 6p, whatever it is, it enters, the last electron enters in which subshell. Okay, take the number 53. I hope everyone is clear. Take the number 53, take the help of the diagram and tell me which subshell the last electron enters. S, P, D, F. Come on. I expect answer from everyone. Take your time, no issues. But do this. Good evening, Sasidharan. Why are you late today? And remove that something what you have stick to the camera, Sasidharan.
Sir, we had like Independence Day March class in our school, so
Oh, today it will be on Monday, no? Probably Monday you have a holiday.
we have like practice sessions.
Oh my God, we have to do the practice for the mass past. Okay, fine. I understand it. Okay. So, but most of you did not attended the PTM. That is not good. You should attend. Yeah. If I get time, I'll talk to everyone's parent after this. Yeah. Now I have you in the class. I'll talk to your parents if I get time. Okay. I hope everyone's parent is at home. Give me a thumbs up if everyone's parent is at home. Yeah. Sindhuja, I saw your parent on the camera. Do not say no. While in the beginning, not now, in the beginning of the class, I saw someone over there. Okay. So you cannot say no now. See, I'm not going to complain. Am I going to complain? Like, what I have to do by complaining about you all? You are my enemy or what? It is all for your benefit. What I will get by talking to your parent? Yeah. So it is for your benefit only. Okay, Sarjana has given us answer. Come on, everyone, quick. Anne has given the answer. We will verify it. Come on, everyone, quick. Anmoldeep has given us a different answer. Okay, interesting. Ragul has given us the answer. Okay, Kevin has given the answer. Okay, Anthony has given the answer. You are doing some mistake, Anmoldeep. Anthony and Anmoldeep, you are doing some mistake. Please count the electrons, count down the total electrons, Sarjana, and tell me the last electron also. How many electron entered in the p subshell? Okay. Yes, Anthony and Muldeep, do it again. Anthony, do it again, and Muldeep, do it again. You're doing some mistake. Sindhuja, I want the answer. Kevin, I'm waiting for your answer. Come on. No, Kevin has given the answer. Fine. Okay, correct, Sarjana. Anthony has given again the wrong answer. Okay, some of you are doing it wrong. Let me recorrect it. Okay, look over here. Those who have got the answer wrong. It is not B block. It is P block. Okay, so I'll correct it till over here. 3D10. Yeah, 3D10 means it is 30. 2, 2, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18 plus 2, 20, 20 plus 10, 30. So after 3D, what we have? We have 4P. Correct. So 4P 6. That is 36. Correct. Then we have 5S. Then we have 5S. Correct. 5S 2. So that is 38. Then after 5S, we have 4D. Correct. We have the 4D after that. So Anthony, over here, correct, and Muldeep, till over here, how much number we have got? 38. So in 4D, how can you get 1? In 4D, I can maximum accommodate 10. So after 38, it has become 48. Then what I have after 4D? I have 5P. Correct? And 5P, how much electrons are remaining? 5. So 5P, 5. Is it clear, Anthony? Now let us check. Now this is what we have done according to our table, according to the trip. Now let us see if it is correct or not. 5P5, 53 atomic number. Where is the 53 atomic number? Come on, find which is the element of the 53 atomic number. Sarjana and Anthony and Muldeep, find 53. Correct, Kevin. It is correct, and it is nothing but iodine. Now 53. Correct, iodine. It is where? It is in the P block. Now to cross verify it, fluorine. We know fluorine is 9. Correct. So 1s2, 2s2, 2p5, 2p5. So this is 2p5, this is 3p5, this is 4p5, and iodine what we have got is 5p5. Hence we are 100% correct. Is it clear, everyone? Is it clear? Yes or no? Give me a yes or no. Is it clear? I hope now, even if someone tells you, tell us the atomic number, electronic configuration of 90, 95, 105. I hope you will be able to do it now. Yes? Shalom. Very good. Yes? One microphone is on. Ganesh, microphone is on. Okay. Shalom. Is everyone clear? Let us go ahead now. Okay. Now let us P block. Yes, your P block is your group 13 to 18. Your P block is group 13 to 18. So now let us remember from your group 13 to 18 all the elements. Now, one more thing. Your group 13, we also call them by the name of the first element. If group 13 over here, the first element, what is this? Boron. So group 13 is also called as boron group. Group 14 is also called as carbon group. Group 15 is also called as nitrogen group. So in the exam, do not get confused. If someone asks you the trend for the nitrogen group, that means they are asking for the whole group. So do not get confused in the exam. When they say a first element in the group, that means the whole group. Okay. Now let us do some mnemonics. With the help of mnemonics, we will remember the at least P block. Okay, we will start with the P block. In next lectures, we'll do the S, D, and F also. Okay, let us do the P block. Okay, let us do the P block. Now, if you want to help with the mnemonic, you are most welcome. Okay, but I have my own mnemonic. I'll start with that. If you have anything better, kindly help. Okay, everyone has their own way to remember it. Okay, so now let us go with the group 13. I'll bring the periodic table also over here. Just a minute. I'll bring the periodic table also over here. Just a minute. Okay, sure. We are doing the P block. So group 13, group 13. Okay, this is the group 13. Group 13. How many of you know this brand? Yeah, group 13. I'll write it horizontally. Okay. How many of you know this brand? From the first alphabet, what we are going to do, we get one brand of that. That is group 13. Okay, it is called as Baggett. Bag it. Yes, bag it. B stands for boron. A stands for aluminium. Yes. Ga stands for gallium. Then you have indium. Yeah. Are you getting it? Then you have tellurium. So over here, thallium. Sorry. So over here, this is how you remember. B for boron. Yes. B. How many of you know this brand? Some of the girls might be knowing it. Yeah. More famous in the girls. It gives all that bag, leather, and all that. Yeah. Baggage. If you do not know, it is fine. But remember this baggage. Okay. Baggage. So in the next lecture, I am going to ask each and every question. Okay. From this now, you do not require this NH. Okay. Nelium, you do not require it. It is fine. Okay. It is discovered in some 2003 or 2006. No need. Okay. What you required is at least till over here. Okay. Then group 14. Group 14 starts from the carbon. Okay. Group 14 starts from the carbon. So I'll write C stands for, let us say, cute. Okay. Cute sisters. Cute sisters get tiny problems. Cute sisters get tiny problems. Cute sister gets tiny problem. Okay, so group 14, it stands for what? C stands for carbon. Yeah, C stands for carbon. Si, yes, what is Si? Si stands for silicon. Correct. Ge stands for germanium. Now Sn, Sn is nothing but what, everyone? Come on, tell me what is Sn? Yes, what is Sn? It is nothing but tin. That's why I have written tiny over there. Yeah, Tin. Yeah, correct, Anmol. Sn is for tin. Okay. Then we have Pb. What is Pb, everyone? Correct, Anthony. What is Pb? Sarjana. And yes, correct. It is nothing but lead. Correct. So carbon, silicon, germanium, tin, and lead. Okay. Correct, Anmoldeep. So cute sisters get tiny problems. Okay. In the next class, I am going to ask where is Ge present. So you have to tell me group 14, third period. So when I ask you, do not say cute sisters get tiny problems. What I will do with that problem? I do not want those problems. I want where exact the element is and tell me about element, not the mnemonic. Okay. Then group 15 starts from nitrogen. Okay, group 15 starts from nitrogen. So nitrogen, I have N for new. So let us say new polis. Okay, new polis assigns subordinate Bikram on duty. Subordinate. Now you can help me over here. Instead of subordinate Bikram, Bikram stands for Bi. That is the Bismuth over here. If you want, you can give me some other name. Bikram is more of a Hindi name. Yeah. So it will be very difficult to remember. Come on, give me any name. Bi. Yeah. Give me any name, some South Indian name. Those who want to stick with Bikram, they can stick with it. But Bi, do we have anyone from the B in the class? Nah. Any name from the B? Come on, give me. You have some actors also from B. Batman, oh my god. Batman. Okay, that is nice name because Batman is related to police also. Biryani. Biryani. Biryani is the name of person. Yeah. I wish my name was chicken biryani, but it is not. I love chicken biryani a lot. Yeah. Sadly, that is not my name. So biryani is not a name. Yeah. Biryani. Hmm. Some or other way we are going to include food over here. Don't worry. Come on, chip in some names from the B. If you want to stick with Bikram, Bikram is also fine. Or you can stay with Batman. Batman is related to police, so Batman is also fine. Butter chicken. Butter chicken, oh my god. Hmm. Billionaire. Okay. I want the name of a person. Like it should make sense, no? New police assigned subordinate Bikram. That makes sense. Bindu. Okay. Bibin. Okay. Bibin is fine. Bindu is also good. Babu. No, Bablu. Bablu. What is this Bablu? Bablu. Okay. You have the actors, and all of the actors, some of the actors now I do not know this, so do not get offended. Some of the actors use this Babu in the end, isn't it? Mahesh Babu. Yeah, I like him. Yeah. Some actors use the Babu in the end. Yeah. Okay, for now we will keep it with Bindu is fine. Chal. Bindu. B-I. Okay. Bindu. Anthony? Who is this Bindu? Hmm? Yes, Anthony? I have to check who is this Bindu. Hmm. Okay, so N, it is not random. I know this, but it is fine. Tell me afterwards when everyone leaves the class. Okay, no issues. N for nitrogen, P for phosphorus, AS. What is AS, everyone? Over here. AS, nitrogen, phosphorus, AS stands for? AS stands for what? AS stands for no one knows? Yeah. Sindhuja, AS stands for what? Arsenic. AS stands for, correct, arsenic. Then you have SB. This is more difficult. SB. How many of you know this SB? Yeah. SB. SB. That S and B not included in the name of that compound at all. Yeah. SB. SB. Which element is SB? Yes. Which element is the SB, Sasidharan? Correct and correct, Anmoldeep. Ragul, Prashanti. Which element is SB? SB is nothing but antimony. We are all pro money. Yeah, we are not anti money. We want money. Yeah, that's why we are studying. Otherwise, we wouldn't have studied also. Yes, SB is anti money. Then BI we have is the bismuth. Okay, BI we have is the bismuth. Okay. Then group 16. Group 16, what we have? The oxygen group. Okay, so we can write over here. Oh, Sima. Now again, you can chip in any name if you want. Sima is again a North Indian name. Oh, Sima sent the post. Oh, Sima sent the post. Oh, Sima sent the post. SE. We have Sarjana with us. We have Sindhuja with us. Yeah, we can include Sindhuja. We can even include Sasidharan. Yeah, but Sindhuja seems better, isn't it? Yeah, Sindhuja. Should we write your name over here? Sindhuja seems better. Oh, Sindhuja, bring your parents for the PTM. Okay, so we will write Sindhuja. Chalo. I'll
tomorrow,
just
sir.
write a different spelling. Okay. Oh, Sindhuja sent a post. Okay. Sindhuja, please send the post to your parents. Okay. So O stands for oxygen. SE stands for, oh no. After first you have is only S. First you have only S. So that stands for sulfur. Then you have Se selenium. Then you have Te tellurium. Po polonium. Po polonium. Okay, is it clear, everyone? Yeah, come on, give me yes or no. What has happened to you? All 18, 17 years old people I have in the class. Yeah. Group 17, I hope we do not require mnemonic for group 17. Do we require? I don't think so. Correct? We always use fluorine, chlorine, bromine, iodine, aspartame. It is on our tongue. Yeah. For group 17, I don't think so we require any. Yeah. But still, chalo, I'll give you. We have F, we have C, we have B. Okay. So F, I'll write first class. Over here, I can use biryani. Yeah. First class biryani in first class biryani in 80. 80. Yes, Sasidaran, what happened?
So 80 can be
80 can be Andhra Pradesh. Do we get a good biryani in Andhra?
why not, sir?
It can be Australia. I want something with the tone of T, like Australia. So 80. Okay. Biryani in Anthony? No, that is fine. Still, Australia is fine. We'll keep the Australia. Yeah. So F stands for fluorine. Cl stands for chlorine. Yes. Br stands for bromine. I stands for iodine. And At stands for aspartame. Yeah. Clear, everyone? Yes. Then you have helium, neon, argon, krypton, xenon, and radon. That you remember. That you remember. Okay, so this is your P block. This is whole your P block. So in the next class, I have spent good 25 minutes on this. So in the next class, I want you to remember these elements. Yes, is it clear? Definitely, I am telling you, I am going to ask you in the next class. Okay, is it clear, everyone? If I forget it, who will remind me? Who will remind me? Anthony, will you remind me? If I forget to ask, yeah. If I forget to ask, who will remind me? Ragul. Okay, fine. Chalo. If I forget any one of you, please remind me. I will not reveal your name who has reminded me. So don't worry. You will not get any bad, bad faith. You will not get anything. Just type in the chat box quietly that you are going to ask the periodic table. Okay? Clear? So in the next class, Sasidaran, that does not mean you will join late in the next class. Okay? You have to join on time, and I am going to ask periodic table. And those who is not going to answer, definitely some punishment I'll give. Definitely some punishment I'll give. Okay? Deal? Everyone, deal? Yeah? Okay, fine. Chalo. Let's see. Okay. Chalo. Now let us start. After this good brief half an hour of P block of the basics, let us now start with the actual chapter. Yes. Let us move to the actual chapter what we have. Okay, so group 15, group 13, group 14, group 15, 13 to 18, everyone we know it is the periodic table. But 13 and 14, it is there in the 11th standard, correct? So we are going to start with the 15, group 15 element. Group 15 element is what we are going to start with, correct? So as I told you, they are also called from the name of their first member. For example, boron. Your boron group, your group 13, the first element is boron. So it is also called as boron group. It is also called as carbon group. It is also called as nitrogen group. Correct? Now, everyone, oxidation states. What do you mean by oxidation state? Yeah? What do you mean by oxidation state? Anyone? Oxidation state. What do you mean by that? What do you mean by that? Oxidation state. Come on. Do not say I know, sir, concept, but I cannot explain. Yeah. Oxidation state is the concept that we know, but we cannot explain, isn't it? We do not know how to write it in the words. What is oxidation state? Yes? What is oxidation state? Oxidation state, Ragul. What is oxidation state? What are you looking at ceiling? The answer is not written over there. What is oxidation state? Anthony? Number of electrons or protons in ions? Not really. Like somewhat yes, but protons in ions. Okay, we can consider that. What else? Come on, it is simple. See, oxidation state. When I say oxidation state in simple words, remember like this. In simple, we do not make it complex. We can give n number of definition from textbook. What is important is you understand. Yeah, in the simple language, oxidation state is simply meaning charge. Charge on your, like, what charge can come on your element. Simple as that. Simple as that. For example, calcium oxidation state is +2. That's why you will always find calcium compounds as CaCl2 because its charge is +2, CaOH twice because charge is +2. Are you getting it? Yeah. So your oxidation state, write it down simply meaning charge. Okay. Now your group 15 elements, nitrogen, phosphorus, arsenic, antimony, bismuth, and your moscovin. Okay, moscovium. Sorry, moscovium. So your P block, if you check P block, this is a periodic table. I'll again show you the periodic table. Okay. Anywhere apart from P block, do we have non-metals? Anywhere apart from P block, do we have non-metals? Yes, come on. Look into the periodic table. Anywhere apart from the P block, do we have non-metals? Do we have non-metals anywhere apart from P block? Yes, Ragul. Correct. And Sajna. Do we have any non-metal apart from present in the P block? See this what you are seeing in orange color. Yeah. This is your P block, non-metals. Correct. Hydrogen, yes, except the P block. See, non-metals are very less. They are present only in the P block. So non-metals are very less. Exception your hydrogen. Yes, hydrogen is the only non-metal what you have apart from your P block. Okay, over here, what we have, most of them are metals. They are alkalinous metal, D block metal, whatever. But only in the P block we have majority of non-metals. Okay. So your group 15 starts with the nitrogen. Group 15 starts with the nitrogen. Okay, Okay, where did we go? Now your group 15, they are also called as what? They are also called as, look over here, where did we go? Group 15, they are also called as nicogens. Always remember group 15, they are also called as nicogens. The compound are called as niconides. Okay. So first two elements of your group 15 are non-metals. Then you have metalloids. Then you have bismuth and moscovium, which is metal. So can we say metallic property? As you go down the group, what is happening, Ragul? From non-metal to metal, you are going towards metal. So can we say as you go down the group in group 15, the metallic property increases. Write it down. Your metallic property increases as you go down the group in the group 15. So in the group 15, your metallic property increases. So general configuration we can write is NS2NP3. We have seen now, everyone knows now how to write down the electronic configuration. Yes. Now, as we have discussed, in the atmosphere, which is the maximum amount of gas we have in the atmosphere, who is dominant? Yeah, who is dominant in the atmosphere? Correct, Ragul. Who is dominant in the atmosphere? Yes, Sindhuja. and Sarjana. Correct. Yes, it is nothing but the nitrogen. Nitrogen is the maximum in the atmosphere. Correct, Kevin? Nitrogen, what we have is the maximum in the atmosphere. And on the earth crust, which is the maximum element? Which element is the maximum in the earth crust? We have done this in the metallurgy. Element, Kevin, not the metal. Not the metal. Aluminium, not the metal. The element. Element. Silicon. Is it? No. No. Arey, you forgot. It is oxygen. I've told you when I say earth, not earth crust. Earth crust is a wrong word. I would say earth. Okay, when I say earth, it includes atmosphere, it includes water, it includes earth crust. So oxygen is the most abundant element. Okay, most abundant element. Okay, so nitrogen is maximum. Now from the earth crust, how do we get nitrogen? We get nitrogen from sodium nitrate, that is nothing but NaNO3. Correct, that is the major source of nitrogen from the earth crust. From the earth crust, that is the major source of nitrogen. Now electronic configuration. Electronic configuration, we have learned how to write down the electronic configuration. Yeah, please do not get confused. They write such elements also. Now why do they write element, Ragul? Why do they write element? Because it is just to make it shorter. Yeah, just to make it shorter. Like for example, if I write down the electronic configuration of element having atomic number 100, so that will take space till over here. Yeah, so what I do, I write down the closest noble gas, I write down the closest noble gas, and I write down the element. For example, phosphorus. Come on everyone, write it down with me. Phosphorus, what will be the electronic configuration, the complete electronic configuration? It is atomic number 15. So Rakul, it will be 1s2, write it down with me, 2s2, 2p6, correct? So 2 plus 2, 4 plus 6, 10. Then what is there? 3s2, correct? Then what we have? 3p3. 3s2, 3p3. So instead of writing this whole thing, what we do is 1s2, 2s2, 2p6. Yeah, is the noble gas electronic configuration of the element neon. Okay, this is the neon. So we write neon, okay, in the square bracket, and then we write 3s2, 3p3. Okay, so please do not get confused with this element. Okay, we write down only the noble gas. One student asked me, sir, why do we write only noble gas? Because noble gas are the only one whose everything is filled, no half filled over there, everything is complete. Yes, that's why we write down the noble gas, and they are stable. Is it clear, everyone? Yeah, so do not get confused with the alphabets in the electronic configuration. Clear, everyone? Okay. Now your s orbital is completely filled. For example, look over here, 3s2, and your p orbital is completely half filled. So we have 3p orbital, and all of them includes 1 electron. Correct? So in the group 15, nitrogen group, your p block is completely half filled. Completely half filled. Okay. Then let us do some important properties. Now look over here, everyone. Atomic radius, or let us say size. 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 As you go down the group, and Anmoldeep, Sasidaran, Sindhuja, as you go down the group, the size of element increase or decrease? The size of the elements increase or decrease? Come on, tell me. As you go down the group, I know little bit theoretical chapter, but bear with me. Yeah, we have to score marks in this also, very easy. As you go down the group, everyone tell me, size increase of the element or does it decrease? Sindhuja, as you go down the group, Sasidaran, does the size increase or decrease? Ragul says decrease, Arjuna says increase, Sasidaran says increase. See, how do you compare size, Ragul? Size means what? From the center of nucleus, if this is my element, look over here, Ragul, this is my element, correct? This in center you have nucleus. First shell, second shell, third shell, so on, correct? So Ragul, when you go down the group, what happens? The shell increase. Shell increase means what? From the center to the outermost shell, this distance will go on increasing. Yes or no? So as you go down the group, the size increases. Now, left to right, does the size increase or decrease? Left to right, does the size increase or decrease? Yes? Come on, all my old 18 years, 17 years students, does it increase or decrease? Come on, my oldie peoples, sit straight and tell me, will it increase or decrease? Okay, Sindhuja says decrease and says decreases. Yes, everyone replied, does it increase or decrease? Okay, Kevin says decrease, decrease. Okay, it decreases. Okay, I assume that it decreases. Why? Like when you go down the group, we are adding electrons, Ragul. We are adding electrons, we are adding protons. So yes, the size increases. But same thing we are doing across the periodic table. When we go from left to right, we are adding the electrons, yes or no? We are adding the proton, yes or no? So why does the size decreases while you go down the group? Size increases. Yes, correct. And yes, Sindhuja, Ragul, Sarjana, come on, tell me. If I go down the group, yes, the size increase. I am adding the proton, I am adding the electron. Yes, the size increase. But same thing I do it when I go from left to right. I'm adding the electron, I'm adding the proton. So why over there the size is decreasing and why down the group size is increasing? Yes, Sasidaran, Sarjana, those who have answered, size decreases. Come on, tell me. Why does it happen like that? So Sarjana, won't it happen in the when you go down the group? Won't it happen when you go down the group? Yeah? Won't it happen when you go down the group? Same thing. Yes, Sasidaran, come on. Prasansi, tell me. Anmoldeep. Okay. Sajna says when the proton increases, the nucleus pull towards electron increases. Okay, I agree. Electrons and protons are increasing. But won't it happen same thing when you go down the group? In that also you are adding the proton and electron. Yeah. So what exactly happens? When you go across from left to right, you are not adding any shells. What is happening,
Sir, while
Prasansi? You are
going
just
from left to right, sir, this is Arjuna, sir.
Sarjana, yeah, come on, tell me.
Sir, from like when you are going from left to side, the electrons are added in the same subshell.
Hmm.
But when you are going from top to bottom, the electrons are added in different subshells, so the size increases.
Okay, fine. So what is happening, everyone? When you go left to right, what is happening? The shells does not increase. The shell does not increase. Let us say I have two shells. I am going left to right. I am adding the same proton in the nucleus. I am adding the electron in the same subshell. So obviously, positive, negative, if it increases at the same position, the more force of attraction is there. We call it as effective nuclear charge. We call it as effective nuclear charge. So if you add proton and electron at the same place, the charge density will increase, they will come close to each other. Yes or no, Prashanti, is it clear? But when you go down the group, you are adding the shell only. Correct? You are increasing the shell. So no matter how many proton and electron you are adding, if the shell increase, you have to take till over here. No? So obviously the size will increase. Is it clear, everyone? Come on, give me yes or no. Is it clear? Is it clear? Okay, so when you go down the group, the size increases. And when you go across, left to right, the size decreases. Okay. So everyone, let us take a break. Yeah. Please come on time. Do not miss it. The lecture. Do not leave the session. Drink water. Take a 5-minute break. We will continue at 8:10. Okay, I want you back by 8:09 so that we can start at 8:10. Okay, kindly do not leave the session and come back. Yes, everyone, come on. Back in the chat box. Turn on your camera. Come on, everyone, back in the chat box. Yes, back. Okay, so let us move ahead. Come on, everyone, back. Okay, turn on your camera, Kirtini, Sasidaran, Rajna, Sindhuja, turn on your camera. Okay, now what we have? Ionization enthalpy. Yes, everyone, ionization enthalpy. Now, ionization, what do you mean by ionization, everyone? Ionization, we have heard about it, isn't it? What is ionization? Yes, when I say ionization, what do I mean by that? Ionization. Yeah, what is ionization? Yes, ionization. What do you mean by ionization? I asked only ionization. What is ionization, everyone? To ionize something. Prashanti, Ragul, Sasidaran. What is ionization? Yes, correct. And that is ionization enthalpy. What is ionization, everyone? Sadhna, Sarjna, Akhilesh. Come on, tell me what is ionization? We know ionization. Come on, we are chemistry students. We know ionization. What is ionization? To ionize something. Atom acquires a charge. Correct? So Prashanti, ionization means what? You remove a single electron. For example, sodium. If I want to ionize the sodium, it will be Na plus electron. Correct? So I am removing an electron. I am removing an electron. So ionization means the energy that is over here, enthalpy. What is the meaning of enthalpy? Enthalpy is nothing but the energy. So energy that is required to ionize your element. Simple as that. Energy required to ionize the element. If the electron, for example, if I go down the group, is it easy? If I go down the group, my size is increasing, not my size, the size of element is increasing. If I go down the group, so is it easy to remove the last electron or is it difficult to remove the last electron? Understand my question properly. If I go down the group, is it easy to remove the electron or is it difficult to remove the electron? Come on, tell me. Is it easy or is it difficult? Yes. Correct, Sarjana. Prashanti. Do not rub your eyes like that. It will become red. Yeah. Come on, tell me. Yes, correct, and correct, Sindhuja. If I go down the group, will it become easy to remove the last electron or is it difficult to remove the last electron? Yes, Raghu, Sasidaran. What will happen? Yes, come on. Kevin, is it easy to, is it difficult? This is difficult. C. Simple as that. Okay, shielding effect and everything is there. But simple, Prashanti, look over here. Simple. You only tell me. As you go down the group, the size increase. Correct? As you go down the group, the size increase. So let us say in the starting elements, I have proton over here, I have electron over here. Correct? So, and as you go down the group, the size goes on increasing, electron and proton go far, far, far. Correct? So what is happening over there? The charge, the attractiveness between your nucleus and the outermost electron is decreasing. So obviously it is easy to remove this electron. It becomes more easy to remove the electron. Plus there are electrons in between which creates the repulsion. So it becomes more easy to remove electron as the size increases, and hence as you go down the group, yes, the enthalpy, ionization enthalpy, the energy that is required is less. As you go down the group, the energy, the enthalpy that is required to ionize your element is less. Hence, what you can see over here as you go down the group, your ionization enthalpy decreases. Is it clear, everyone? Come on, give me yes or no. Is it clear? Is it clear? Yes. So one thing always remember, ionization enthalpy 1 will always and always less than ionization enthalpy 2, and that will always and always less than ionization enthalpy 3. Ionization enthalpy 2 means what? You are removing 2 electrons. Ionization enthalpy 3 means what? You are removing 3 electrons. So no matter what, this will always be followed. Ionization enthalpy 1 will be less than ionization enthalpy 2 and ionization enthalpy 3. Is it clear, everyone? Yes? Okay. Now as you go down the group, obviously the density size is increasing, the density also increases. Same is the melting point and boiling point. As you go down the group, it increases. Okay. Now, one thing I wanted to discuss atomic radius and ionic radius. What is ionic radius? Yes, Prashanti. What do we mean by ionic radius, Ragul, Sashidharan, Anmoldeep, and Sarchna? What do we mean by ionic radius? Yeah, what is this ionic radius? Why do we have this ionic radius? Yeah. And one more question. Why over here? Why there is so much of difference, Sashidharan? Why there is so much of difference between atomic radius and ionic radius? If you look, 70 and 171, it is more than double. Yeah. Yes, Sashidharan.
Sir, ionic radius is the distance between the center of the ion to the outermost valence electron.
Okay. And what is then atomic radius? Isn't it the same thing?
Yes, sir. But it is an atom.
So
So
what is the difference over here?
in an ion, like we will be removing electrons. Like ion is something electrons removed from an atom.
Is it only when we remove electron we get ion? Is it so? We can get ion even if we are adding the electron.
Adding also.
So that is why you can see over here, Sashidharan. Over here we are not removing electron. We are adding the electron. N3 minus. Okay. The nitrogen, phosphorus, and arsenic, they are more stable in 3 minus. We are adding electron. We are not removing it. Okay. And that is the reason over here, this such huge difference. That is the reason when you add the electron, the repulsion will increase. And when you add the electron, the size will increase. Are you getting it? Yes. So that is the reason. If I remove electron, like what I am doing in antimony and bismuth, the size will decrease. Yes, the size will decrease. But I add the electron, the size will increase. Is it clear, everyone? Is it clear? The difference between atomic and ionic radius? Yes. Okay. Let us go ahead. Atomic radius and ionic radius. So you can see that's why there is a such huge difference between them. Okay, that is why. Okay. Now let us move to electronegativity. Yes, let us move to electronegativity. Yes, can anyone tell me what is electronegativity? Yes, we all know as you go down the group, we have seen in fluorine, chlorine, bromine, iodine, electronegativity decreases. Yes, that is same followed over here also as you go down the group, electronegativity decreases. But Prashansky, Anmoldeep, Kevin, Sashidharan, what exactly is electronegativity? What do you mean by electronegativity? Yeah, what do we mean by electronegativity? Yes, what do we mean by electronegativity? Correct, Sajna.
So tendency of an atom to attract a pair of electrons.
Okay, good. Ability to attract shared pair of electron, tendency to pull electron. Correct. So electronegativity means what, everyone? It is basically tendency to pull electron towards itself. Electronegative element always try to pull electron towards itself. For example, fluorine. The most electronegative element in the periodic table. Why does it pull the electron? Why does it want the electron? Because The electronic configuration is 2,7. It requires only one electron. Question C. It requires only one electron to complete its octet. That is why it is always trying to steal the electron. It is always trying to pull the electron. That's why fluorine is electronegative. Are you getting it, everyone? So as you go down the group, due to the increase in size, the electronegativity decreases. So remember, down the group, electronegativity decreases. Electronegativity decreases. Now, look over here. We have C metallic character increases down the group. Correct? We are going from there. These are mostly polyatomic. What do you mean by polyatomic, everyone? Yes? What do you mean by polyatomic? What do you mean by polyatomic? Yeah? What do we mean by polyatomic? Come on, tell me. Polyatomic. What is the meaning of that? Don't say polyatom, we have many atoms. Correct. And yes, Arjuna, what do you mean by polyatomic? Prashanti, Ragul, Sasidharan, what do you mean by polyatomic? Yeah? Polyatomic. Polyatomic. More than one atom. Obviously, it is polyatom. It is written polyatom. So you cannot define it as more than one atom. Give me any example. Give me any example. Yes, what do we mean by polyatomic? Nitrogen is polyatomic. Phosphorus is polyatomic. What is the meaning of that?
So sulfur,
Yes, Sasidharan.
sulfate ion.
Sulfate ion? No. We are talking about sulfur. Okay, sulfur. So sulfur, what happened to sulfur?
Sir, in sulfate ion, it has more than one.
Why we are only looking at sulfate ion?
So, for example,
No. I am talking like if I consider sulfate ion, I am included oxygen also. I do not want that. I am just talking about sulfur. Sajna, if I say carbon dioxide, I am including oxygen also. So what do we mean by polyatomic? Okay, chalo, I'll tell you. Okay, oxygen, Sachidhanan, in atmosphere. When we say oxygen, what is oxygen? Yes, Prashanti. When we say oxygen, I am breathing oxygen. Do oxygen exist as O in the atmosphere? Yes, Arjuna. Does oxygen exist as O in the atmosphere? O3. Oh my God. Do we breathe ozone? Sachidhanan? When I say
for example,
O, when I say
ozone is polyatomic.
Okay. Now over here, when I say oxygen, I mean O2. We breathe O2 gas. O will never exist as a single atom, isn't it, Prashanti? O will never exist as a single atom. Always and always you will find oxygen in O2. Yes. Similarly, nitrogen, it is always an N2. Phosphorus is P4. Sulfur is S8. Yeah. So they are always in the polyatomic form. You will never find them in nature in monoatomic form. Like helium, like neon, they are generally in the monoatomic form. Yeah, your metals, your gold, silver, they can be in the monoatomic form. But your group 15 elements, they are polyatomic. Is it clear, everyone? I hope everyone is clear with the polyatomic word. Yes? Okay. Now, oxidation states. Come on, give me yes or no. Everyone is clear with the polyatomic word. What has happened? I know theoretical chapter, but we have to score marks in this also. Yeah? Highly weightage, the most marks containing chapter. Yeah? Come on, be focused. Oxidation states. We have discussed what are oxidation states. Oxidation states are nothing but simply charge. Over here, you can see the charge. So, your group 15, they have a tendency -3 oxidation decreases down the group. What is the meaning of that? That means if I have a question of having NCl3 and BCl3, BCl3 may not exist. I am just giving you as an example. BiCl3, bismuth. Okay. It may not exist. I'm just giving you the example. Okay. So over here, or let us say instead of NCl3, let us say NH3. Okay, not NCl3, NH3, ammonia, NH3. What is the oxidation state of N over here, everyone? What is the oxidation state of N? What charge is present on nitrogen over here? Yes. What charge is present on the nitrogen? Sashikaran says +3. What charge is present, everyone? Come on, reply in the chat box. What charge is present on the nitrogen over there in NH3? +3. What charge is present on the nitrogen? Charjna, Prashanti, Ragul. What charge is present on the nitrogen over here? +3. Is it? Is nitrogen +3 over here? How to find oxidation state? Take nitrogen as X. How do we find oxidation states? What +3, +3, +3? One someone answers +3, everyone is +3. Nitrogen, if I am finding out the oxidation state for nitrogen, what I'll do, I'll take nitrogen as X. What is charge on the hydrogen? Yes, single hydrogen, the charge is +1. So it is +3 is equal to 0. +3 goes that side. What is the charge? How can it be +3? Come on, please explain me. It is -3. So if I have NH3 and BiH3 and question comes. Yes, Sasidaran?
So instead of plus minus, I wrote it.
Okay. So if I have question NH3 and BiH3, yes, I got it. Everyone took it as -3. X -3 is equal to 0. This silly mistake we have to avoid. You can do mistake over here, but not in the exam. Correct? So over here I have NH3. Over here I have BiH3. Now everyone, nitrogen, bismuth. Now the question comes, which is more stable? Then what you have to look, we know one thing, as you go down the group in group 15, -3 oxidation state stability decreases. -3 oxidation state stability decreases. So you are comparing nitrogen -3 and bismuth -3. So we know that as I go down the group, the stability of -3 is decreasing. You will not look at the size now. You are looking at the stability. Of your atom. In your NH3, your nitrogen is -3, BiH3, your bismuth is -3. We know that as we go down the group, the -3 oxidation state stability decreases in the group 15. So obviously, bismuth -3 will be the less stable than nitrogen -3. Are you getting it? And these questions are common. Your -3 oxidation state stability decreases as we go down the group. Yeah? Is it clear? Because the size is increasing, it becomes difficult to add the electrons. As the size increases, it becomes easy to give away the electron. But as the size increases, it becomes difficult to add the electron. Hence, the bismuth -3 is less stable than the nitrogen -3. Is it clear, Prashanti, Sarjana? Come on, give me yes or no. Is it clear? Sinduja and Kevin, is it clear? Okay. So +5 and +3. Now again, -3, +5, it decreases, and +3 increases. Remember, group 15, write it down. -3 +5, stability decreases, +3 increases. Now one more question. Nitrogen. Okay, I know that I have seen a compound like PCl5. Okay, I know I have seen a compound like PCl5. Okay, but a compound like NCl5, does it exist or no? If yes, then why? If no, then why? NCl5, does it exist? Anyone have seen it in the chemistry? I have seen PCl5, I remember. I have seen it, I can tell you. But have you seen NCl5 in the chemistry? Yes, come on, tell me. Does NCl5 exist? does NCl5 exist? Okay, I'll tell you it does not exist. Now you tell me why it does not exist. Like nitrogen will not like 5 chlorine attached to it. Okay, is it so? Why does nitrogen do not like 5 chlorine attached to it? Why NCl5 will not exist? What do you think? It does not exist. I'll tell you it does not exist. Okay,
So,
Sasidharan, yeah.
plus 5 oxidation state of nitrogen is highly unstable. So,
Why? That is the question. Why it is unstable?
because in the 15th group,
Hmm.
stability of plus 5 oxidation state decreases. So, down the group, so nitrogen will be
So nitrogen is the first element. According to that logic, it must be the most stable element. Then. It is decreasing down the group. That means first element should be stable. Yes, Sarjana says it will be not stable even if it is formed. So that is the question. Like why it is not stable even if it is formed? Okay,
Sir,
look over here.
nitrogen
Nitrogen is
has
kind.
only
Yes,
nitrogen
and
has
correct.
only two shells, so it does not
Hmm.
have a d orbital. So
Hmm.
5 electrons from chlorine will be harder for it to handle, whereas in phosphorus it already has third shell. D orbital is not filled, so it can easily be filled and it will be stable.
Correct. See, first of all, yes, correct, and you're correct. Slightly, I'll like to improve that answer. Okay. You said it will, first of all, NCl5 will not form only. Forget about stability, instability. NCl5 will not form only. Why? Okay, where like in 11th standard you must have learned about VBT in the chemical bond. Okay, I do not expect you to remember. Those who are in the booster batch, I have taught you the VBT, the bonding little bit. Okay, but look over here. Nitrogen. Nitrogen, what is the atomic number? It is 7. If I write down the electronic configuration 1s2, 2s2, 2p, 3, no, 2p, 2, 2p, 3. 1s2, 2s2, 2p, 3. After 2p, what do we have? After 2p, what do we have? After 2p, yes, after 1s, 2s, 2p, what do we have? Everyone? 3s. We do not have 2d. We do not have orbital on the same energy level. So what happened due to that? And I'll improve that answer a little bit. What happened due to that? Over here, I have 1s, I have 2s, okay? I have 2p. Okay, I have 2p. I do not have at all 2d. Yes, same energy level. I do not have any orbital over there. Okay, so what happens over here? 2s2, 2p3. Now PCl5 and Cl5 they are forming a covalent bond. Correct? They are forming a covalent bond. If I have to form a bond with nitrogen, I have to fill electron over here, and only 3 half-filled orbitals are there. There is no extra 2 half-filled. If in the phosphorus I have 3d also, in the phosphorus I have 3d also. Correct. So what happens? Your s electron jump in that. S electron jump in that, and I get 5 half-filled orbital. So in that I can put my 5 chlorine. 1 chlorine, 2 chlorine, 3, 4, 5. But I do not have anything like that for my nitrogen. Are you getting it, everyone? I cannot put this electron in d orbital because I do not have 2d only. 2d does not exist. After this, I have 3s, and 3s is the next energy level. You cannot jump like 2 from 3. Are you getting it, everyone? You can jump electron among the 2s, 2p, but you cannot go in the direct energy 3. Yes, is it clear, everyone? I do not have 3d over here. My 2s electron cannot jump. I just have 3 half-filled orbital, and hence only and only 3 bonds are possible over there, and I can get NCl5, NCl3, and that is the reason nitrogen has a lone pair of electrons. These are the lone pair of electrons. Are you getting it, everyone? Come on, give me yes or no. Is it clear? Yes, is it clear why your NCl5 does not exist? Because 2D does not exist. Yes, Sasidharan?
Sir,
Yes, Sasidharan, what happened?
sir, this is Anthony, sir. Can you
Anthony, yes,
explain?
yes. Acha, I'll explain it 1 second. Okay. Anthony, when we did the electronic configuration, yes, we did the electronic configuration, correct? So we had done 1s2, 1s. Then what we had in the electronic configuration, Anthony, we had 2s, we had 2p, we had 3s, 3p, 4s, 3D. Correct? 4s 3D. This is what we have in the electronic configuration. Correct, Sajna? We have this in the electronic configuration, Anthony. So I have 1s, 2s, 2p. Okay. So 2s and 2p are at the same energy level. Correct? So I have 2 electrons in 2s. Anthony, I have 3 electrons in 2p. I do not have anything like 2D. Do I have anything like 2D? No, I do not have anything like 2D. That's why, Anthony, this electron, these 2 electrons, they cannot move. They are present over there only. Okay. And in the 2p, Anthony, I have 3 electron half it. Over there, I can put the electrons of chlorine and I can form a bond and I can make NCl3. So NCl 1, 2, 3. But Anthony, I cannot move this orbit, I cannot move this electron, hence NCl5 is not possible, I can only form NCl2. But in phosphorus, Anthony, when I move, I have 3s, 3p, I even have 3d. I even have 3d. So in that case, Anthony, my 2s electrons, yes, I'll again draw it, not 2s, this time it will be 3s. Then I have 3p, then I have 3d, yes. Anthony, I have 3s, 3p, 3d. So over here in the 3s, I have 2 electron, 1 electron, 2 electron, 3 electron. Now over here, Anthony, my 3s electron, it can jump in 3d because it has d orbital on the same energy 3, 3, 3. But I do not have 2d. 2d does not exist. Correct? So if the electron jumps, what will happen? This electron will come over here. Anthony, now I have 5 half-filled orbitals. Now I can put electrons over there and I can form a bond. So I can form 5 bond, hence 1 chlorine, 2 chlorine, 3 chlorine, 4 chlorine, 5 chlorine. Is it clear, Anthony? And it goes to everyone. Is it clear now? Prashanti? Is it clear? Anthony, is it clear? Come on, give me yes or no. Sasidaran and Anmoldeep, Kevin. Is it clear, everyone? Let us go ahead. Okay. Now nitrogen. Nitrogen, if you look, is a very versatile. Nitrogen is very versatile. Okay. Nitrogen is very versatile. It has almost all of the oxidation state. For example, look over here. From -3, it has oxidation state till +5. From -3, it has oxidation state till +5. Now the question will come in your mind that why we did not had NCl5 over here if it can go till +5. But if you notice, +4, +5, it will always and always exist as a diatomic, N2, N2. It will never be N single N. They can combine and they can go to +4 and +5, but your single nitrogen cannot go in +5. Are you getting it, everyone? Yeah. So over here, -3 to +5. For example, if I have to calculate, how do I calculate? N2O3. Yes, come on, tell me. What will be the oxidation state of nitrogen over here? Calculated by our method N2O3. N2O3, come on, calculate it. N2O3. Oxidation state of nitrogen over here. N2O3. Come on, everyone. Are no one knows? Come on. N2O3, what will be the oxidation state of single nitrogen over there? Prashanti, no one knows how to calculate oxidation state. Kevin, Sasidaran, come on. What will be the oxidation state over here? N2O3. Correct, Anmol, correct, Sindhuja, Sadhana. What will be the oxidation state? Correct, and yes, Sasidaran, Sindhuja. What will be the oxidation state over here? Yes, Anthony. What will be the oxidation state? Sasidaran, +6. Is it? I am asking about single nitrogen, Sasidaran. I am asking about single nitrogen. Okay. Look over here. How to calculate? Those who do not know, Anthony. Correct. Perfect. So over here, I have nitrogen. I'll take it as X. How many nitrogen I have? I have 2X. I do not have 2X. Nitrogen I am considering as X. So it is 2X. Oxygen is minus 2. Correct, Prashanti. Oxygen is minus 2. So 3 into minus 2, that is minus 6, is equal to 0. Minus 6 goes that side, becomes plus 6. X is equal to. Are you getting it, everyone? So nitrogen over here, N2O3, it is plus 3. So look over here, nitrogen trioxide. So the point is, nitrogen is very versatile. Sarjana, nitrogen is very versatile. It can go from minus 3 to minus 2 till plus 5. Yeah. And even phosphorus, see, in the group 15, the oxidation state is generally minus 3, plus 5. But nitrogen is so versatile, it can go from minus 3 to plus 5. It can go till minus 3 to plus 5. Is it clear, everyone? Come on, give me yes in the chat box if it is clear. Come on, give me yes in the chat box. Yeah? Okay, fine. Now, disproportionation. What do you mean by disproportionation? Yes, everyone? Let us move to the chemical properties. Disproportionation. What do we mean by disproportionation? Yeah? What do you mean by disproportionation? Come on, tell me. Disproportionation. What do we mean by that? Okay. And what is the meaning of that? And yes, Arjuna, Prashanti, Ragul, Sasidaran. What do we mean by disproportionation?
Like the same element could have the different oxidation state in element side and in reactant and product side.
Is it
It
so?
would be
Like that happens in every reaction. If I do any reaction,
no.
yes,
You will get two different products in which we will have different oxidation states.
and different oxidation states. So what happens? So like how do we get different oxidation states? What do we call them? If the oxidation state changes, what do we call it? Like for example, I'm going from plus 3 to plus 2. What is happening to that element?
Reduction, sir.
Yes, exactly. So disproportionation means what? It is meaning the same element is undergoing, do not say two oxidation state. To be precise, the same element is undergoing oxidation as well as reduction. That is how you get two oxidation state. Are you getting it? And why did I corrected you? If I have plus 3, I can even get plus 2 plus 1. But that is not the case. That is not the case. I am not getting two different oxidation states. Two different oxidation state means I can have plus 2 also, plus 1 also. But that is not the case. Over here, I am getting plus 5 and plus 2. That means what? One is undergoing oxidation, one is undergoing reduction. Is it clear, everyone? Disproportionation reaction means what? Write it down. Same element or atom undergoes oxidation as well as reduction. Same element or atom, it undergoes oxidation as well as reduction. Is it clear? Come on, give me yes, everyone. What has happened? Is it clear? So sorry. Okay. So over here we can see, everyone, we have the nitrous acid. If I decompose the nitrous acid, what is happening? Nitrous acid HNO2. If I calculate the oxidation state of nitrogen, it is X. Hydrogen is plus 1. Oxygen is minus 2. 2 oxygen minus 4. It is 0. Goes to that side, becomes 4 minus 1. It becomes plus 3. Correct? So over here, from nitrous acid, Prashanti, it is going to nitric acid as well as nitric oxide. So why we are learning over here? Because your group 15 elements has the property of disproportionation. It can undergo oxidation as well as it can undergo reduction. Example is this. Come on, write down this two reaction. Come on. Nitrous acid giving you nitric acid plus nitric oxide. So one time it is undergoing oxidation. While it goes oxidation, it forms nitric acid. If it undergoes reduction, it forms nitric oxide. So both product of oxidation as well as reduction, I get it in the same reaction. Same thing over here, phosphorus acid +3 to +5 oxidation and reduction, that is -3. Come on, write down this two reaction and done in the chat box. Yes, everyone, come on, write it down and done in the chat box. Write it down, write down the two reactions, write down the oxidation state as well. Write down the oxidation state as well. Come on, tell me. Is it done? Write it down and done in the chat box. Okay, sure. Let us go to the next. Let us go to the next. Okay. Now, yes, nitrogen and phosphorus. Yes, it's good, but antimony, bismuth, arsenic. Yes, Sasidaran. No,
Sir,
antimony.
sir, last slide, sir, please, sir.
Acha. Write it down. Chalo. Write it. Go to the. Write it down. Just write it down, everyone. Anthony, is it done? Come on, tell me, is it done? Okay, there is also done. Okay, fine. So let us go to the next. Let us go to the next. Okay. Now look over here. Disproportionation. After that, we have. I'll come to the covalency, but first look at the anomalous behavior. Now, anomalous behavior. Okay, we know as we go down the group. Okay, as we go down the group, the electronegativity decreases, ionization enthalpy decreases. So why we are considering this as anomaly? Why we are considering this as anomaly? Okay. Why we are considering electronegativity, high electronegativity as anomaly over here? Anomaly means what? It is showing some different behavior. Anomaly means it is showing some different behavior. Correct? So over here it is saying high electronegativity. Over here it is saying high ionization enthalpy. Correct? So why it is an anomaly? Why it is a different behavior? We know that as we go down the group, the electronegativity decreases. So why it is a different behavior? Because as you compare, let us go to our comparison. If you compare the ionization enthalpy, the electronegativity, where did it go? Electronegativity over here. Okay. If you compare the electronegativity, everyone, look at it. 3. Okay. And while everyone is 2, 2, 1.9, 1.9. So all this electronegativity are comparable. All this electronegativity are comparable, but nitrogen is only one which is having electronegativity of 3. Are you getting it? So all the first elements from your group, they show anomaly behavior first is due to their size. Due to their size, mostly they are gaseous in nature. Due to their size and gaseous in nature, due to that, they show some of the anomaly. They show some of the anomaly behavior. So you have high electronegativity, high ionization enthalpies, all of the property, bond enthalpy high. It cannot form, we discussed this also, cannot form d pi p pi bond. Yes. So all of this property, all of the property of nitrogen, we consider it as anomaly. due to its small size, due to the size of your nitrogen is small, and the properties, yes, it goes according to our rule, but the properties are very, very high. The size is very, very small. The electronegativity is very, very high as compared to the other elements. That's why we consider all of the properties as anomalous properties of nitrogen. Is it clear, Prashansi? Is it clear, Sajna? Yes? Is it clear? Okay. Now look over here. Your chemical reactivity. Let us come to chemical reactivity. We discussed this a little bit. Yes, hydrides, formation of hydride. So if I react anything, like for example, I reacted nitrogen with hydrogen. Yes, we get what? If I react nitrogen and hydrogen, I get ammonia. Yes, what is this? Ammonia. Which process is this? This is your Haber's process. This is your Haber's process. Correct? We prepare ammonia with the help of Haber's process. If I mix nitrogen and hydrogen, I will get ammonia, which is nothing but a hydride of nitrogen. Yes, but we have seen as we go down the group, the -3 oxidation state decreases. The stability decreases. Hence, over here, BiH3 does not exactly form also. But yes, if you react it with hydrogen, this methane can be formed. That is BiH3. Is it clear, everyone? Okay. So look over here, BiH3 does not form only. Okay, BiH3 generally does not exist only. It is very unstable. Immediately it goes away. Immediately it goes away. Okay, immediately it goes away. So stability we know as we go down the group. Yes, over here they will not exist. They will not exist. That's why the boiling point and all those should decrease. But yes, it shows some of the anomaly. It shows some of the anomaly. This numbers are not important. Numbers are not important. Yes, they show anomaly, but you should remember as you go down the group, the stability decreases. Is it clear, everyone? Yes. Then we have the binary metal compound. Now look over here. If I react it with water, okay, your metal compounds over here, Mg3N2. What is the oxidation state of nitrogen over here, everyone? What is the charge of nitrogen over here? Yes, Sajna, Prashansi. What is the charge of nitrogen over here? And Anthony. Okay, so these are your metallic compound, ionic compound. In the ionic compound, how do we know the charge? Do the cross. One student asked me yesterday why it is not Mg3N. Yeah, why it is N2? Why it is not Mg3N? Because we know the charge on magnesium always and always it will be +2. Nitrogen it is -3. Correct? So it is exchange. Mg3N2. Yes, Mg3N2. Yeah, so if I always and always remember, if I have alkali metals, if I have alkali metals like magnesium, like calcium, if I react them with water, yes, I have Mg +3, I have Mg +2, I have nitrogen -3. I am reacting it with water, Sajna, Prashansi, I am reacting it with water. So what is the meaning of that? Water means I have H, I have OH minus. So H plus will go with the nitrogen, and we have seen when nitrogen -3 reacts with hydrogen, what does it form? It forms hydride of nitrogen. Correct? Similarly, if I have OH and alkali metal, what it will form? It will form hydroxide. Is it clear, everyone? Come on, write down these reactions. Come on, quickly write down the reaction. Nitrides, if I hydrolyze nitrides, what I'll get? I'll get hydroxides and hydrides. I'll get hydroxides and the hydrides. Come on, write down. And done in the chat box. Come on, write down. Sindhuja, write it down. Sindhuja, write down what I have told you. Write down the reaction. Sindhuja. Sindhuja, am I audible to you?
Yes, sir.
What happened, Sindhuja, whom you are talking?
My mother was here, sir.
Acha. Come on, write it down. Focus
Yes,
in the
sir.
class. Write it down and done in the chat box. So this is how you remember the reaction. See, remembering the P block reactions are not easy, I understand, but this is how you remember it. Okay? From the oxidation state, from the charges, try to remember it. You will find it easy. Otherwise, you will find it very difficult. Okay? Otherwise, you will find it very difficult. Okay, now oxides, reactivity towards oxygen. Don't worry, in 4-5 minutes we'll start with the class assessment. I can see your face, you are already tired. How much is left? We have oxides. But the question might include the remaining PPT also. Okay, the questions might include remaining PPT also. So don't worry, I'll cover the the remaining thing tomorrow. Okay, if you miss out on some question, not worry. Okay, try to answer it honestly, how much you know. Should we start with class assessment? Let us start this oxide thing tomorrow. Yeah, I feel I have seen your faces. Do not make such faces. It is fine. I am stopping now. I know it is P block, it is theory.